Okay, here's the Bernoulli example problem. We got to figure out a couple things. We've got this large tank of water that is 25 meters high. It's filled with salt water and a plug near the bottom, 5 meters from the bottom, with a cross-sectional area of 4 times 10 to the minus fifth square meters. We're going to figure out the force exerted on the plug before the plug bursts. If then the plug pops out, what's the speed of the water exiting the hole, and then the volume flow rate. So first thing, forces. All right. Pressure equals force per unit area. We rearrange this to figure out that force is equal to pressure times the area, right? We want to know the force. That's our real question. We're given the area, 4 times 10 to the minus fifth square meters. We need to calculate the pressure. Okay, we need to calculate the pressure. Well, how do we figure out the pressure? Pressure equals the atmospheric pressure plus the gauge pressure. The atmospheric pressure is going to be pushing right. The tank is open, so here we're going to have atmospheric pressure. Basically 100,000 pascals is standard atmospheric pressure. Plus the gauge pressure, rho g h. Rho for salt water is 1,025 kilograms per cubic meter. G, we're on planet Earth, 9.81 meters per second squared. And H, here's a little tricky. This was 5 meters up from the bottom. This whole thing was 25 meters high. So that means the height of water stacked on top was 20 meters. So you grab your calculator, you multiply 1025 by 9.81 by 20, you get 201,105. 201,105 pascals. So the pressure equals that plus that, 301,105 pascals. That's not quite the answer. The question was, what's the force? Force is equal to pressure times area. So we take 301,105 pascals multiplied by the area of 4 times 10 to the minus fifth meters squared. Times 4 second E minus 5 gives us 12 newtons. The force is equal to 12 newtons. There's your answer, the first one. Now, second part. Calculate the speed of the water. This one we need to use Bernoulli. Bernoulli's equation is kind of a long thing, but when you do this equation, always write it out. Write the whole thing out. A couple of good shortcuts here, or tips to remember, but write out the equation is the first thing. P1 plus rho g y1 plus 1/2 rho v1 squared equals P2 plus rho g y2 plus 1/2 rho v2 squared. Long equation. Just got to memorize it. Well, you don't have to memorize it. Look up the reference tables, but you write it out the whole time. Up here, the air is pushing it down, and out here, the air is pushing there. So nothing's being done. Atmospheric pressure will cancel out atmospheric pressure. Make this level's height 0. Make y2 0. That means this goes away, and so y1 is 20 meters above. Well, we just figured out rho g y1 over here was 201,105 pascals, plus we're going to assume the water up here is motionless. It has no velocity. So that means this goes to 0. Velocity equals 0. If the velocity equals 0, that whole thing goes to 0. So 201,105 pascals is going to be equal to 1/2 density of the salt water, rho, 1,025 kilograms per cubic meter times V2 squared. It's a conservation of energy. This much gravitational potential energy becomes this much kinetic energy. But you write it all out. Make sure you set the lowest point equal to 0. And then it's really pretty straightforward. So now you've got 201,105 pascals equals 1/2 125 kilograms per meter cubed times V2 squared. 201,105 times 2 divided by 1025, 392.4 equals V2 squared. And so V is going to equal the square root of that, 19.8. 19.8 meters per second. That's V2. The water shoots out here. The water is shooting out here with a speed 19.8 meters per second. Okay, and then the last part, the volume flow rate. The volume flow rate. The volume flow rate. Volume flow rate is area times velocity. So you've got your area of 4 times 10 to the minus 5th square meters times 19.8 meters per second. See how we're going to get cubic meters per second. So we'll get our volume flow rate. A volume of cubic meters divided by seconds. 4 second E minus 5 times 19.8. Hit the right buttons. 4 second E negative 5 times 19.8. 7.92 times 10 to the negative 4th. 7.92 times 10 to the minus 4th cubic meters per second. Done. All right, all good.